work. And by the end of today, if you have not sent me the team forming information, you need to do this by today, okay? And I thank you in advance for your cooperation. And then I can just fine tune the teams a little bit based on my needs. So this Wednesday we will have our first lab, and the first lab I'm going to teach you on how to wear the traditional control relay. So this lab, we will not touch the PLC, and I will teach you how to wear the system for the control relay. So nobody, if you have anything that prevent you from attending this the next Monday's meeting, and you need to talk with the Dr. Condor. Okay? As I said, because of the nature of this class and the hands-on experience, you cannot get your credits without attending this hands-on sessions. But I will give this is the final decision making authority to the Condor. If Condor says okay, I'm okay. So last time, just like the last week. Actually, no, right? This is Monday. On this Monday, we have learned the instructions. We have learned XIC, exam if closed, exam if open, and OTE. OTE is the full the output instruction. OTL is a latch output instruction. OTU is unlatch output instruction, along with OSR. OSR stands for one-shot raising. One-shot raising. As the name suggests, this guy, if the input status change from the false to true, the OSR will become true, and will be true only for one cycle. After this cycle, this guy becomes the false again. So this is why this guy is called a one-shot raising. So this is what we have learned in this Monday's class. And then we talk about the general steps in planning a PLC. So whenever you give a task and to control some systems. So this is the general these are general steps, and for you guys to do this is to design PLC diagram before you wear the system, before you write the ladder diagram using the software. So what you are going to do, and you need to define the process to be controlled, and you need to what will be controlled, and draw a sketch of the process, including all sensors and the manual controls needed to carry out the control sequence. So you need to have a piece of paper. Use your pencil. It's better to use a pencil. Okay, why? Because if you use a pencil, you can just erase and to modify it. Use a pencil. Draw this system. You need to think about all the sensors, and you can get information from outside. And all the actuators needs to be implemented to take some actions. You need to all know all these things. And then you need at least a sequence of the operational steps in as much detail as possible. So sequence, and what will be checked first, and what will be checked later. What is the sequence of your checking the checking sequence? What is the checking sequence? And when you want to control this system, you need to ask yourself, and usually when you do these kind of things, if this is a very, very big project and you will have multiple team members working together. However, if this is not very, very big, usually you yourself will be in charge of everything here. Okay. So to be complete, you need to have all these sensors, all these actuators, and how you are going to do, and how to, and what condition and some what actions will be taken, and what condition and what actions will be taken. So you need to be familiar with all these control tasks. Okay? And then you can write the ladder diagram to be used as for the PLC program. You can write in this is on a piece of paper instead of just go use the software directly. If you are experienced the PLC programmer, that's okay. But now because you guys are entry level young guy, and I would suggest that you just do something on a piece of paper. That helps. And so you need to consider different scenarios where the process sequence may go astray and make adjustments as needed. And because this is the logic, okay, the logic controller, it means that if some conditions are met, and what I'm going to do, sometimes we have multiple scenarios, right? Multiple scenarios. Scenario one, and what I'm going to do this. Scenario two, I'm going to do that. Scenario three, I'm going to do this. So on and so forth. And you need to consider all these scenarios. You understand, guys? And when you do a very, very important job, and you should not ignore any possible scenarios. If you ignore these possible scenarios, when you implement this program in the PLC, if these conditions, if this scenario, if it happens for this scenario, and your system will become a dummy, it can do a lot of random, maybe some harmful things for you. You understand, guys? So you as an operator, okay, this is you should take the responsibility. So you cannot blame the machine. You understand, guys? You cannot blame the machine because you say, oh, I just ignore one scenario, but the machine did not recognize. No, this is not excuse. And you are operator, and you are responsible for everything, and the machine will be doing either bad one or good one. If good things, and you get the credits. If bad things, and you need to consider. You understand, guys? I need to tell you, and we are operating the system, not the system operating us. So as a result, we are the final decision maker. You understand? So with that being said, you need to consider all these scenarios. If you ignore one or two scenarios, as I said, when this actually, this is in the reality, when this happens, and this system will become dummy. This guy does not know how to handle and what kind of actions will be taken. This guy will give you something random, maneuver, random operations. Also, you need to consider the safety of operating personnel. Yourself, you need to consider yourself, and you need to consider other people and who will be operating the PLC system in reality. You understand, guys? So actually, these steps are very general for all this is the programming for this is the entry level engineers, and we just use a white piece of paper, with pencil to draw some ladder diagrams here, and then we consider all these scenarios, then I'll finish these things, and you can just implement in the PLC using the PLC program. Any questions regarding this slide? No question? No question. So here is our application number one. This is application number one. It's a simple one. So here is our PLC. So here is our PLC. We have input. This is the input module, and so this is output module. And input module is a switch. We just use a very, very simple switch. And output module, we connect motor. This M stands for the motor. M stands for motor. And what we want this guy to do is that if we turn on the switch, and I want to turn on the motor. Okay? So here, so if we do not, for this one, if we do not use the PLC, if we use the traditional control relay, and it goes this way. If we have this diagram. When people use the control relay many years ago before PLC appeared, okay, and they do the same thing as we do now. So they also for this PLC, for this is the relay, they also need to draw two legs. Okay, this ladder, just a ladder. So as I said, for the control relay, so this left leg stands for the power, right? Stands for the power. and the red leg stands for the ground. Can you write down, guys? Because next Monday, this is our first lab session, and I will ask you guys to wear the system, wear the control relay, and using the physical wears. So this is power. We have power, and we have this is the ground. The power left leg. Well, you can see, you just follow. Okay, after you finish this letter diagram, when you wear the system, you just follow the diagram, round by round. So here, that means the power goes to the one end, one terminal of this switch. This is the switch, and the switch, another switch of this guy, another terminal of this guy, and will be connected to this motor. One terminal of the motor, another terminal of the motor, and will be connected to the ground. And then you can finish the first round. And then for other rounds, you just go one by one. This is for control relay. And however, because the appearance of so after this PLC, people use the PLC, and we have different things. And so this is just very similar. We also use this is the ladder. Okay, this ladder. And for this one, we also treat this one as power, and here we treat this one as a ground. So, but when you just connect this one and this one, so you think about this. This is must have a address. Also, input has address. This output has address as well. You understand? You can see. So here is instruction. If this instruction is true, so this motor will be energized. I can just imagine. If this one is true, the water or electrical current can go through from the left leg through this one and reach this is a motor. As a result, this motor will be energized, will be turned on. And whenever I say energized, it means so this guy is turned on. Question so far? Now, the difference between this one and this one is when you wear these two legs. So this is the power, physical power. So this is the physical ground. You understand? But for this PLC, no. The PLC, input module and output module. And these two guys are not physically connected. However, here, so these two guys are physically connected. But for the PLC, these two guys are not physically connected. So this one will be connected to the input module. So this guy will be connected to the output module. And how these two guys are connected? They are connected using this diagram. Wait.
Yeah, what does the COM terminal mean?
This COM here is the ground. We can say a common, the common terminal. Common terminal is usually, we can see to be strict, okay? The common and the ground is different. Common here means that this is the same voltage level that we use to compare everything. You understand, guys? The same reference level. The reference, common here is used as a reference for voltage. So one more time. In the control relay, the diagram, the components, they are physically connected. However, in the PLC, we will not say the components, the instructions, they are not physically connected. They are connected using ladder diagram, but each of these instructions, they are connected to either input module or output module. Questions so far? No question? No question, we go to this one. This is a very, very important one. And I want to tell you guys, for almost every control system, we have these kind of things. So why this one is called important is the start, stop, and seal-in circuit. So here is our control relay, okay? So here control relay, we have this ladder diagram, we have a stop sign there, not stop sign, stop button, okay, sorry. The stop button, we have a start button, and we have a motor, And so this is a motor auxiliary. So this is it means that this guy and they are using the same address, right? They are using the same address. And how does this guy work? It means that, okay, how this work? At the very beginning, and the motor stops, motor does not rotate. And if you press the start button, then the water or electrical current can go through from the left leg, go through the stop button, then go here and to reach this arm, okay? And reach this arm, after this arm is energized, and so this guy will become true. This guy will become energized. Energized also means the turn on. So because this guy and this guy have the same address, so after this guy is energized, then even if you just release the start button, after you release the start button, the water can still go through using this way to reach this is the motor. So this is called start, stop, seal-in circuit. It means that if we press the start button once, and then the motor is energized, then I release the start button, and then the motor still remain on. So this is called start, stop, seal-in circuit. You understand that? So this is very important for our quiz 2 or exam 2. I will test your understanding. So for the PLC, the same thing. For the PLC, the same thing. Okay, you can see start, stop. These are the buttons, and they are connected to this is input module, and this motor is connected to this output module. If I press the start button, and then the motor will be turned on and will remain on even after I release the start button momentarily. So this is called start, stop, and seal-in circuit. For here, I need to tell you guys, for the PLC, our stop button is special. Write down, guys. For our PLC, our stop button is special. Our stop button is always true until you press it. Can you write down, guys? Our stop button is always true until you press it. If you press it, this guy turn off, this guy is turned off, and then something will be shut off. But if you do not press it, this guy is true. So that means, so here the stop button here, this sign need to be close to this. That means just like this one, and they are close. This is important. So otherwise, in the later on the PLC implementation, and you'll be confused. One more time, the stop button for the PLC, for our PLC stations, is always true until you press it to turn it off.
Wait, the start button is always true?
Stop.
Yeah.
The start button is always false until you press it.
What does MOX stand for?
What? MR?
-aux, the component below the start button.
Yeah, MOX means, so this guy has the same address as the motor. So this guy is just the auxiliary part. Good question. That's for here, okay, for the relay. And for this PLC, so these two guys just use the same address.
Okay.
The same address, that means input instruction can also have the output address. Questions regarding this start, stop, seal-in circuit? No? Then we look at this one. The motor stops in typical start, seal-in circuit or start, stop, seal-in circuit. And for here, so this is my stop one. I stop one. I put this operator line here. I put this. Aiden, you are Aiden?
For the
What's your name?
Hayden.
Hayden.
For the circuit before with the M auxiliary, is the M auxiliary like, is it a stand-in for a motor controller?
Yes.
Okay.
Yes. Yes, you are right. And so for here, this is a PLC. Whenever you see this, let me tell you guys, okay? Whenever you see this sign means that this guy is always the force before you press it. Whenever you see this sign, we have an oblique line here. This guy means that this guy is always true until you press it. You understand? Be very, very careful, okay? And for this one, and this is always true. And that means at the very beginning, the water can go through here, but it's stopped here. However, if I press this button, and I can energize this motor. After I energize this motor, even though I release the start button momentarily, the water can still go through this branch to reach the motor. As a result, this motor will be remaining on until you press this stop button to stop everything, to shut off the water or current, the clear or the electrical current for the whole branch. So this is what on start stop series circuit, or you can call stop start the circuit. So forward, for this is the forward reverse the circuit. Now this is here is the physical. This is the physical wiring. And start, reverse, start, forward, and stop sign. So this is the PLC, and this is the forward direction, and this is the reverse direction. And how can I control these two guys? So as I said, whenever you see this sign, it means that so they are true all the time until you press it. Okay, for here, okay? Well, this is at the very beginning, I'm telling you, at the very beginning, and both this one and this one are false. You understand? At the very beginning, this one and this one, they are false. That means it's not running. Now, because this is a force, this is a force, this guy, and they have the same address. This guy and this guy has the same address. As a result, this guy is a force, so this guy will be true because this oblique line means opposite. Oblique line means opposite. So this guy is force, so this guy is true, right? You understand? If this guy is true, if I press this start button, then the water can go through from this left leg through this one, go here, and reach this one. As a result, this guy will be energized, right? So this guy is energized, then this guy will be true because this one and this one, they have the same address, right? And then, so this, my motor, this one, think from this is one, this is a one, so this is a two, so this is a 1, 1, so this guy is forward. So my motor will be rotating forward direction until you press this stop button and to stop it. You understand? Also, when this guy is true, so this guy will be false, right? When this guy is a force, no matter how you press this one, it doesn't work. Just can just safeguard, just can make sure my motor, you can only control the motor in one direction at one time. The same thing for this round. I want you guys to think about this one by yourself before you go to bed this evening. You need to go through this to make sure and what I said makes sense to you. Okay? The most important thing is the oblique line means opposite. Oblique line, that's this one if I have the same address, and then I have another one with opposite line. Opposite line means the opposite of this guy, itself. You understand? For this one, if you want to change the direction, you must stop it first, and then press either forward or reverse. And you cannot change it before you click the you click the stop button. The stop button must be pressed before changing the directions. You understand, guys? I might give you the same one, okay? The same the diagram, asking you to use your own language to paraphrase. So this one, and the switch direction without stopping and with indicator. For this one, guys, okay, for this one, and we also have start, reverse, start F, and stop button, along with forward, reverse. This is green light and red light. So we can have now we have so this stop button, start button, 0, 1, 2. So this guy, and they are opposite. So here, I 0, 3. Okay, I'm sorry, guys. If you pull out your diagram and change it here. So this is I 0, 3. Change that. Change that. This is I 0, 3. That means this guy is opposite to this guy. Right? So also the same thing. This is also 0, 2. This guy is opposite to this guy. So how it works, guys? You can see, okay, at the very beginning, when we compare this diagram with the previous one, we found that we have this extra one. All other things, they are the same. But how it works, I'll show you guys. I'll just show you one diagram. How it works, at the very beginning, and this is false, and this is false, right? So at the very beginning, because this guy is false, so this guy's opposite is true. So this guy is also false. So also, at the very beginning, this guy, you did not press anything. So this guy is a false. So this guy's opposite here is also true. That means for this round, 2, 2, 2 at the very beginning. Kevin.
Is it I02? Is that what you said right there?
I02, 03.
No, the one below that. Is it
Here,
yeah, is that
I1, I02.
okay.
That means this guy and this guy, they share the same address.
I was just making sure.
Yeah, okay. So as I said, at the very beginning, this is true, and also this is true. And then if I press this start button, then this guy is true. So that means the water can go from here through this one, through this one, through this one, through this one. And then the water reaches, this is the motor. And then the motor is energized, okay? After the motor is energized, because this guy and this guy, they have an address, same address. This guy is energized means that this guy is turned on, this guy is true, this guy is true, then this guy is true. So after this guy turns true, then even after I release the start button momentarily, the water can go through this way. As a result, my motor will be turned on, remain on until you click the stop button to shut it off. Alright? You can see guys, after this guy turned on, okay, now for some reason, if you want to change the direction, once you click this guy, once you look at me, look at my finger, guys. Once you click this guy becomes true, and then this guy's opposite will become the false. If this guy is a false, so this guy will be turned off immediately. Questions? The same thing for this round. The same thing for this round. When we compare this diagram and the previous one, and we can find that, and we only ended this and this respectively for these two rounds. Okay, then
So if they share the same address, if one has the slash through it and one is open, they'll have opposite values. So if like say it's open, say that's like false, will the other one of the other rung be true? Like if it has the line through it?
Yeah, so the slash, whenever you see the slash, okay,
Yeah,
if the slash means this is opposite to something.
okay,
For example, this is 03, 03, I03. That means this one and this one, they are opposite.
okay,
If you do not have the same address, just as this guy means that this guy is always true.
yeah,
That means you can just think, my switch is turned on. You can see one terminal, I have another one. You can just treat this oblique line as an arm. Okay, this arm connect these two gap, fill this gap. That means the water can go through this one. This is how I memorize these things when I was a student. And how can I intuitively imagine how it works? I just think water or electrical current. Okay? If everything is true, I just assume the water or electrical current can reach this is the output, from this is the power. So this is how I memorize things. And this might be useful for you, helpful for you. If you have another way and to memorize this one intuitively, you are welcome to use other way. But this is just my way, okay? I think this is very intuitive, just water. If you cut it off, if this one turn off, that means the water cannot go through, or the electrical cannot go through. You understand?
Yeah.
Pay attention to this one. I definitely will test your understanding of this. I'm sorry, guys. So here is a 0. Here is a 0. And so this diagram, I copied this diagram from the textbook. The textbook is not right. Questions so far? So then we talk about a very more complicated one. This is can be a mini project for people. You can see, okay. So what we want to do now, and suppose we have this is the conveyor belt. We have one roller, another roller, and these two rollers we have sensor 1, and to detect that something is put on this conveyor. So some operator is here, and another operator is here, and after the operator put some workpiece at here, the sensor knows that. When the sensor detects some new workpiece, then the conveyor belt will be rotating and to take this workpiece from here and to here, then stop. If this guy has no holes here, right? If this guy has no hole, and also there is a sensor, So this is sensor this is the drilling machine, is a drilling bit, is in this position. Then the drilling bit need to go down and to reach this workpiece, and then if there is no hole, and they need to drill a hole. After the hole is drilled, then this guy will be taken away from this position to here. Then the sensor 3 knows that some drilled the workpiece has reached this point. Then another point operator will take this off. So this is a control system, control tasks we want to accomplish. Questions? For this, how can we control? And think about this one. The sensors, actuators, and here the actuators include the conveyor belt. This conveyor belt will be rotating and to take the workpiece from one location to another. And when this is a drill bit and will be going down, and when the drill bit will be rotating, when the drill bit will be retracted onto the safe position. And so then this is the workpiece, drilled workpiece can be moved from the sensor position of sensor 2 and to the position of sensor 3. So you just think about this one. Let's just think about this. I'm going to go through this one kind of very quickly. Now look at this diagram first. As I said, always for all this is a control system. and you need to always put the start stop swing circuit for the first round. So this gives you an option, flexibility. Whenever you see something bad is going to happen or happens, you just shut it off. I'll do that. So start. I have system on, right? So this guy is always on. When after I turn this start button, the system on is full, and then you can do all these rounds. However, if I see something bad, I just click this stop, and then the system on will be turned on, will be turned off. So all other rounds will be shut off. You understand? First round, whenever you do these kind of things, on first round, you always put start, stop, swing circuit there. So here, so this is what we want to do. Okay? The system must be on to do things. System is on, the drill status, the drill status must be off. If drill status is off, because this oblique line, so this guy is true, right? And also the object status also must be off. And then this is a sensor one. If your sensor one detects something, then the conveyor belt will be latched. Sensors? You can see, latch the conveyor motor when the system is on, the drill status is off. The drill status, you don't want to drill a hole on the conveyor belt, do you want? No, right? The drill bit must be off, then you can move. Otherwise, if this guy, the drill bit is turned on, and then you just move it, you just cut it off. This is the conveyor belt in the middle. You agree? That's a better thing. So the drill status must be off. The undrilled object is present at the sensor one. So see, sensor one detects undrilled things. The drilled object is present at the sensor two. Or okay, so this is or. I have a sensor two, have a drilled one. I have a drilled one at sensor two. Then I need to move this drilled one to the sensor three. Or I have sensor one, I have undrilled one, and undrilled one, and then I can move latch this conveyor belt. This makes sense to you, right? Okay, you can see I have taken care of all these scenarios. So third row. On third row, unlatch the conveyor belt when the three conditions are met. And what condition and you need to unlatch the conveyor belt? So first, yeah, the drill status is on. If the drill status is on, the drill is rotating, you must shut off the conveyor belt. Second, an object is present at the sensor 3. If the drilled object is already at the sensor 3, if you still move the conveyor belt, it will fall. Right? This is understandable. A third one, an undrilled object at the sensor 2. At the sensor 2, I detect there is an undrilled one. I'm going to drill this guy. Then the conveyor belt needs to stop here. So if these three conditions, either one is met, I need to unlatch this conveyor belt. You can see I need to consider all these scenarios. As I said, if you ignore one or two scenarios, and in reality, if this is the case, sometimes so this guy will do something very, very crazy. So drill status, right? If drill status is on, drill status is going to drill. Sensor 3 has detect something, or this is undrilled object at sensor 2. This is sensor 2 undrilled. And if either of these three conditions is met, I need to stop the conveyor belt. The next one. So latch the drill motor and latch the drill motor. Okay, latch the drill motor. The drill motor, drill actuator, and drill status when these conditions are met. So the system must be on. The drill status is off. The conveyor belt it must be off. And undrilled object is detected by the sensor 2. And also the drill head is under sensor 4. Sensor 4 is it reaches the undrilled bit. So if these 4 conditions are on, the drill bit can rotate. So you need to unlatch the drill actuator and object status when the drill head is at sensor 5. If this one is true, and you need to unlatch this one. So unlatch the drill motor and the drill status when the object status is on and the drill head is at sensor 4. If these 2 conditions are met simultaneously, so the motor needs to be unlatched. The drill status needs to be unlatched. And then we have unlatch all motors when the system is off. When the system is off, and you need to unlatch all these motors. Conveyor motor, D actuator, this is D motor, and unlatch the object. This is the bit when a new object is placed. So new object is placed as sensor 2. Okay, S2 means here means what? It's opposite of sensor, right? Right, guys? So this is pretty much what we have on for this is the mini one, the bigger project. And then we talk about this is this one very quickly. We have 1 minute. So as I said, it's OSR. Okay, how it works. I want you guys to know and how to use your own language to tell me. So this is a sensor. If this sensor goes from false to true, and then the OSR, okay, then the OSR will be turned on and will remain on for 1 cycle. If this guy is from false to true, this guy is turned on. So that means this guy is true. Okay. At the very beginning, guys. At the very beginning, the light is off. I just suppose at the very beginning, light is off. If the light is off, this is the opposite sign. So this guy will be true, right? Do you have sense? This guy is true, and then because this guy for the 1 cycle, this guy is true, true. So the water can go through this branch and reach this light. As a result, the light will be turned on. Right? The light will be turned on even after this cycle. After this cycle, this is OSR bit is turned off. As a result, this is opposite will be true. Because now the light is already on. True. The after 1 cycle, this water can still go through this branch to reach the light. As a result, if this guy turns from false to true, the light will be turned on and will remain on until this guy detects another thing.